separately. Right. So what's the name of this exam? What is the official name? Uh, okay. All right. Cool. Oh, they also call it UGB. Okay. Part B. Okay. Part B. All right. Hmm. Okay. All right. If f of f like this. Oh. Oh, sorry. F of f. Like this. All right. Okay. F prime of f of x. Okay. So you have to answer both. Or okay. Hmm? Hmm? Okay. Differentiate in the equation, of course. Uh, okay. You will get, what will you get? F prime. Okay. Right. Okay. Correct. Oh, oh, wait, this one? No, here. This one. Oh God, how can you put that? Okay, you did that. Fine. Okay. Okay. Right. The chain rule is always like that only, right? Yeah. Yeah. G prime X, and then you do F prime and evaluate it at Gx. This is a very simple question. Correct. What kind of function? Oh, do you have any example of such functions? Uh, okay. All right. Okay. Huh. Okay. Assume that range of F. Okay. Hmm. Okay. Hmm. Hmm. Okay. Okay. Show is R. Okay. So how do you show this? Hmm. All right. Mm-hmm. Mm-hmm. For some for some x or what? Why? But right, right. But for some x, f prime x could be zero, right? No? Yeah, you cannot have, and I don't know, okay, maxima minima something like so for some x it could be like it could be zero. It's not like for every x it is non-zero. So this was range of f, right? Not f prime. Range of f. Okay. These are okay. Let's think. All right. Yeah, so B is a maximal, right? B is a maxima, right? So F prime X naught, F prime C. So the point is that F, so if you restrict F to the range of F, right, then F is the identity function, right? That is given in the functional equation. So F restricted to this is actually equal to the identity function, right? Which means that the graph of F will be something like this. Yeah, and that's yeah, so like this. And this B, and the B is a maxima that's in the definition, right? Right. So then B is maxima, which means that if B is attained at if B is attained at X naught, right, then F prime X naught is equal to 0, right? And F prime B is also equal to 0, right? So after this, it has to go down, and then it can again to reason that it cannot or something, do like this. Basically, you have to get some contradiction. Uh-huh. Right. So you will get a contradiction, but basically you have to show that it is there is no maxima, there is no local maxima. That is the way. So if B is if the range is minus infinity to B, then B is the is so B is a local maxima, and it is the global maxima by definition. And F of B is B, and F prime B is 0, and B is the first time when F of B is equal to B. Yeah, B is the first time when B is attained in the range. So that's the smallest, yeah, point where, yeah. But then what do you say after that? Yeah, so if there is some X naught where it is again attained, then what do you say? Mm, we have to show that this cannot happen. We have to show that this cannot happen. So, and we have to use the previous part, obviously, as you were using, but yeah, let's see. Hmm. So, some X naught. Mm, right. So I think if you, so you see, if that B is not attained again, if the B is only attained once, right? If the B is only attained once, then can you show that the range uh, is all? No, sorry. 1 minute. So let us think. So F of B is equal to B, and then in this neighborhood it is decreasing, and the derivative is 0, right? If that B is never uh, attained again, then it means that the function yes, sorry, screen went off. Right. So let's try this. I mean, even if this is the last question that we try, let's finish it somehow. Let's do it. So yeah. Let's try it. Oh, I'm trying to share my screen. Oh, I lost my connection again. Yeah, one second. Yeah, I think you're also a bit tired, but we'll do this question and then we'll let you go. Yeah, yeah. So how far was the center from your place? Today's ISI? Oh, wow. So you got lucky. Okay, no problem. Okay. Okay, okay. Right, right. So you live in Bangalore only. So how far is your home from ISI Bangalore? Oh, okay, okay. Have you ever gone there? No, not yet. Not yet. Okay. All right. I've been there once for the interview only, the math interview. Yeah, yeah, Bangalore. I say Kolkata is I've been, I mean, many, many times. Yeah. Okay. Let us, so let us just write, let's just write the main things. Okay, because I have not shared it. Yeah. I've okay. So see, by the intermediate value theorem, the range will always be one of those. Okay. So that is not a thing. Yeah, that is just like that. But yeah, so this is let's draw the graph. So that observation you saw, right? That it is identity on its range. Right? Any point which is on the range that will be sent to itself. So if we assume that the range stops, which is actually it indeed looks wrong, right? That the range should not stop intuitively, kind of, but yeah, then we have to show there is a contradiction. So something like this. Yeah. So from here, we are getting that there is a B where FB is equal to B. And of course, as we should consider this F prime B is 0. Right. Okay, but you see, but the left hand derivative is not 0, right? It's 1 and it is differentiable, so it cannot be 0. So that's a contradiction. And uh, the derivative is not 0, it is increasing at yeah, yeah. The derivative is 1, exactly, as you said. Right, done. Right. So, yes. And because maybe you did not consider that it is identity on the left side. I don't know. if you consider, because see, when we were taking some x naught where f of x naught is equal to b, we were not getting much ideas, right? But when we said that f of b is equal to b, then we said, okay, b ke pehle it will all be like identity or something, right? All that. And we have used everything in a very crisp, like everything has got used if you see. Yes, it is maybe, I don't know. It's an interesting question. Yeah. Okay, let's do that one. Sure. Okay. If G. Okay, so this was a question which you did in the exam. That means you wrote. Okay. 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 Okay, but you were able to do it, so that's good. And so the other ones you attempted partially or something like that. Hmm. Okay. 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 No problem. Right. So let's do then. Let's do if G. So what about G? Oh, again I got disconnected or what? Oh my God, what is happening? It's too bad. Uh-huh. Okay. Rational root theorem, all right. Okay, we can try. We can try. So let's see. Let's try that one G1 first. Let's do that one and then right. Okay. So say right. Sorry. I don't know what is happening. Yeah. All right. Ah, triple. Okay. 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 Enough. It's differentiable. That was the right. Huh. Okay. Mm-hmm. Right. Mm-hmm. Hmm. Once again. Okay. I'll just write it like this. All right. Okay. Okay. Hmm. Right. Okay. Right. Nice. This is just, but yeah, okay. Oh, no, for g of x naught less than x naught. Right. So you can, yeah. Good. So this is again, see this question you got a hand, right? Directly. Like you could just directly use the strictly increasing and that and just, yeah. Yeah, this for two times it was, it doesn't come unique, right? Right? I mean, if this is given, okay, all right, all right. I mean, that's what we already proved in the previous problem, right? We actually proved that the range is all of R and its identity on its range. So we proved it. we just, yeah, we just proved that, right? In disguise. Okay. So then this is fine. You want to try the algebra question? Okay, then let's try, right? Hmm? Okay. So this is question number B3. All right. Okay. There exists a unique real number R. Okay. Let's call it something. Anything it's called? Okay. Sorry. You already said R. Sorry. Okay. Hmm? Such that only one. Okay. 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 Show. Yes. Yeah. That's okay. This one you would have done, right? Yeah. No, no, but this is also easy, right? First one is also easy. Yeah, that is just rational. I see that. But first one is, so why is the first one difficult? No, no, yeah, yeah, but you see, px would be what? Px, r has to be a repeated root, right? R has to be a right, and then you have to, you if you just right, uh, yeah. So it's rational, right? I mean, the product of the complex roots will also be rational. Will be a rational number, right? Uh, right. Yes. How do you? Yeah, exactly. Let's see. Um, right. That is easy because that's the sum of the roots is rational and divided by 4 is, yeah. Right. And in, yeah, but in this case, you are right. In this case, maybe I just skipped. No. So you, right. So you want to show that it has a repeated roots. Repeated roots are always bad. Not okay. Then they're good. Okay. All right. So it's, so let's see. So there is like, if this is no, no, no. So if you write z, how should we write z? It's already x is u plus iv maybe. Right. So we have that u square plus v square times r square. This is rational. right? This is rational. And then you also know that this is rational. Yeah, so from here, correct. R plus U is rational. Okay. So, right. You're correct. I mean, it may not be that this product of roots may not be that useful. Uh, hmm. Okay. So the real root has to be rational. Correct. Hmm. So, oh yeah, that's fine. Uh, hmm. Then, yeah. Hmm. Okay. You want to do that? Okay. No, but I will just take P prime X. I'll just take P prime X and just take the GCD of P and P prime X. That's it. That's what I'm saying. That is it. No, because yeah. No, that's fine because I mean you've not done polynomials for a very long time, right? It's okay. But it's very simple. See, so you know that any repeated root is a common root, right? P of r equal to 0 and P of r prime is also equal to 0, right? So, and r is the only common root, right? Which means that x minus r is the only common factor. Yeah, so if x minus r is a GCD, but you know the GCD, the process by which we find GCD, this will be a polynomial QX, and it will so this polynomial will also be a rational polynomial. This polynomial will only have rational coefficients, right? If you call this fx, then this will have only rational coefficients because the process of finding GCD is like Euclidean algorithm, right? Right. So R is rational. uh, X minus R has rational coefficients, which means one is rational and R is right. So GCD is a very nice thing. So because the any two polynomials, they may have very strange roots in common. Okay, root 2 plus square root of 3, fourth root of all of that. Okay, and another polynomial Q may also have that same root in common. But the GCD will tell you that there will be some other roots also in common, so that finally the polynomial that is in common has rational coefficients. Because the process of finding GCD is a very nice one. Okay, and there are more mysteries in GCD which you will learn formally. Okay, which kind of are not mysteries. It's kind of saying that there is a symmetry in the roots of polynomials. If you have a polynomial which has coefficients which are nice, okay, and then something is a root, then there are some other things also which are roots, so that the combination of those roots is nice. It's something like that, right? Yeah. Like for example, yeah, very small manifestation of that is conjugates. If something is a root, then its conjugate is a root. But you will learn that this runs much deeper. Okay, it's called Galois theory. Okay, you will, yeah, you will learn about. Then you should read it. Then you should read it at the right. Okay, that's that's good. Yeah, so that's the kind of thing which is there. So this is it. This is very easy. Yeah, this is the better thing is to use GCD. Yeah. Okay, so then let us stop, right? Let us stop here. I think, yeah, we have solved a lot of questions, and yeah, I will suggest that you start reading one book seriously, any one book. Maybe you can read Bartle and Sherbet, right? Because, yeah, right. Okay. Right. Then you can think of that. Can, yeah. Mm-hmm. Mm-hmm. Yes. I mean, I agree with you. Yeah, you will, yeah, certainly if you try, you will get. Um, and also this time you had other exams, right? You have board exams, and so you can kind of feel it is just that your preparation was not complete. But anyways, it's never complete. Yeah. So like even if I solve this, I would not be able to solve all the questions in those 3 hours or whatever is the time. Okay. So yeah, you can see. I will not completely say 100% that you should take a drop. Okay. But I will leave that decision to you. Whatever decision you take, it will be yours. Okay. Uh, hmm, okay. Uh-huh. BSc honors course. Uh-huh. As I say in CMI, exactly. So yes, that is what I'm saying. That these days things are changing. ISI and CMI are not the only institutes, okay, where one can learn good mathematics. But yes, of course, there is a difference. But right, you. Hmm, yes, yes, you can do. Yeah, that. Yeah, I don't know if that is, then you'll be in two minds always. But yeah, you think about it, okay? Think about it. But you see, I will suggest that regardless of what you do, you see, this ISI CMI entrance exam is very different from Olympiads. Okay, it's very different in the sense that things follow from very simple things. Okay, but one has to pick up the ability to see those things, right? And I will suggest that if you just start learning some college maths, okay, in a serious way, right? That will just solve all the problems. I believe so. I believe obviously you have to practice the MCQs and so on. That will not be solved. But for example, these questions, they just become like water. Okay, like even that derivative question, why am I able to solve? I'm not even thinking, I'm just sitting, right? Just sitting and just, you know, not thinking very hard also. It's just that, and I have not solved any questions like this in last time I solved with you only. Okay. But it is just that you have to think of good mathematics always. Okay. Uh, basically some very general mathematics which implies all these things. Okay. Not from a sense of, like, okay, if I learn these advanced things and I can do those simple things. No, it's a process of learning those advanced things that will push you, okay, to think of mathematics in a certain way. And then anything you look, you can just kind of, you can, just unpack it. It's like that. It will be like at least these questions. Okay, I'm not saying Putnam questions, that's a different level. But yeah, so you should, like, even if you're preparing for, even if you take a drop and you prepare, or you join a college, make sure that you are very, very patiently learning a very few topics very deeply. Okay, deeply doesn't mean that encyclopedic knowledge, but deeply, in my opinion, means that you take one book and you take one exercise book and you just stick to that and you just churn it out. Okay, slowly and gradually. Okay, that you will see, that will really give you the, yeah, it will just make you good at, just make you very very different. So you can pick up, you can take either Bartle and Sherbet analysis, or you can take, at this point you can start anything. Okay, you can take Hoffman and Kuhn's linear algebra, you can take Artin. Okay, those books, any book you pick, but pick that and do it. If it's slow fast, don't worry about it. You have yourself, you have the internet, I am there. Okay, do it. But make sure that for long hours of the day you are sitting just with the book and the exercise book. Okay, and just patiently reading it. And yeah, okay, then you will see some, you will, because you have a lot of talent. I mean, you, and I'm just saying that, like, you are able to grasp things very quickly, but you have to, but you have to have the right things to grasp, right? What you need to grasp. Because if you keep, like, for example, if you keep solving mock tests, and if you keep, like, doing more and more tricky problems, those things are obviously good that you have to do. Okay, but yeah, that will not be very efficient. Okay, or whatever, I mean, that is something which is up to you, you do. But this, you should sit with some good mathematics. Okay, you should, for some time. Yeah, consistently. That will be very rewarding. Yeah. Hmm. Okay, so if I'm given these two options, I will say that the first one is better. Yeah, first one is better. Yeah, right. But you see, but I will suggest that, do not think in this way. Do not think that I will know many things and then I can solve these questions easily. Okay, I know. I also think like that. I mean, I do, even for semester exams we do that. But you should just think that I will make myself good so that I can solve, I can sit with any problem and I can just keep trying them without any problem, without getting bored of it, without getting frustrated of it. You see, right? It should be like anything that someone starts to talk about mathematics with you about any topic, you should have the ability to sit and listen and, cross check, ask, build on that, and just forget about time. Right, so that anything you are faced with, you should be like that. I'll make myself, because see, it's not mathematics is not just about learning and learning large amounts of things, but it's also about learning to do mathematics, so that anything that you're faced with, you can pick it up, you can learn the techniques of that thing, and you can apply it in the correct way. Okay, right. Yes, yes, exactly. Which is what one has to develop, because otherwise, even if you do a BSc in CMI, after that you will not be able to do research. You will, yeah, you will realize that no, I do not have it. I don't have the temper. But that temper nobody has. One has to develop, right? So that it should be like that. Okay, any question? Like, for example, I have a bad habit. Like, I see a question about polynomials and I start thinking all the stuff I've learned about polynomials. Okay, no. First, neutrally, I should read the question, right? And then just do what is asked, right? Just do what is asked neutrally. Neutrality is very very important, right? Don't be afraid of anything, but that, not being afraid, being neutral, that will come when you develop the temper, right? Just make mathematics your friend, and just be very honestly work with it for long hours. And then, yeah, obviously you will, sometimes you will get bored, sometimes you'll feel you don't like it, but see, nothing is exciting. Anything that is exciting is exciting for some time. Okay, after that it requires discipline for it to remain exciting. Otherwise, nothing is exciting, will remain exciting for a long life, right? You have to build on things, then only it will, you will look forward to it the next day, right? So it's like that. So it may not be very, as I'm just saying, that it may not be very exciting, it may not be very, it may feel like you're not doing anything, but you have to be patient and disciplined, and then it will hopefully be interesting. Yeah. Yeah, so yeah, I will say that if you want to write again next year, then you can just take a drop and you can prepare. Okay. Huh. Yeah, yeah. Then I think, right. If you want to try next year, then you can just sit and try. But you should let the results come out after that. Then, but if you do that, then it should not be that 24 hours you are only preparing, only doing the that preparation. You have to do the higher maths also. Otherwise, you will be, yeah. Otherwise, it's not good. Okay. No, if you take a drop, like if you completely take a drop, even then you should learn the higher maths. Okay. And it is not to become higher, it's just to move forward because you have to move forward. Okay. Moving forward is the only thing. Otherwise, it's not good. Okay. And when you move forward, you will, because mathematics is a very linear subject, right? Why do I remember these things? I'm not reading these things, right? But because mathematics, that's the nature of mathematics. That's why it's an interesting subject. So if you do real analysis from Bartle and Sherbet, then you will not forget these analysis, right? You'll only get better. Okay. So yeah. So that's it. Uh, again, yeah, you will be, but after that, after some time, the field will be evened out. Okay. But and then your mathematical temper will help you. Okay, like you're in a class full of people who are all equal to you, no problem. You're just working, right? Through your temper you can work and move as fast as you as forward as much forward as you can. So for that you have to develop that thing. Okay, that challenge yourself. Okay, so make, then after that you can make a plan that, okay, I'll read this Barton and Sherbet for this many hours, and after that I'll do this. Okay, analyze yourself. All right. Okay. Mm-hmm. Mm-hmm. It will be enough. I suggest you do both of them parallelly. Okay, do not keep one thing that, okay, now exams are coming, so I'll stop studying that, or exams are 10 months later, so I won't study. No, it's not like that. You do things parallelly, that will be best. Okay, then you can see things more realistically. You can see things as they are. I mean, if you do them parallelly, doing higher maths, when you sit with it, when you work out the exercises, that is like solving problems, but provided you do them honestly, actively, right? uh, right. And you will do that, I suppose, right? And you will learn to do that. So do them parallelly, don't keep anything aside. Okay, do those things, don't do too many things. Do as much as you can. Let's say two things, do them parallelly, then you can see the connections. Yeah. And things, then it's, yeah. Okay. There is, see, don't never think that there is lack of time. There is enough time. Think about how you can make yourself more focused, more efficient. Not in the sense of seeking shortcuts, but more efficient. That's the thing. Like, I know that for myself also. There is enough time. If you actually study a very focused way, then 4 5 hours, you cannot actually study for more than 4 hours, let's say Rudin or Bartlett Sherwood, if you actually can. So that you have to see, where you are losing your focus, where what is, going, and that you have to collect in one place and converge. Right? There is enough time. Don't worry about time. Think about the quality, how to increase the quality. Okay, I actually making progress. Like, you will realize after 1 month that, oh, I did this thing last month, and I was could not do, and again I'm not able to do. That is the troubling, that you should solve. That, okay, once I do something, I should be able to replicate it next time. I should make myself good, right? In general, the muscles should grow, right? It's like that. So, right, that you have to track. Okay, and then it's, yeah. Anyways, do it and then let me know, yeah, if there is anything. Yeah. Okay. All right then. Take care. Okay. I'll end the meeting. Yeah, so right now, look, I don't have any exams. So, I mean, what would you prefer, morning or evening, or what would you prefer? I mean, I think morning is fine. Maybe Tuesday morning if you want, or yeah. Hello? Oh, my connection is gone.